Hey guys, this is Mrs. Utag here. Tonight we're going to be doing a video on the area of a non-right triangle. Before we start off this video, this is a great time to grab a snack, get something healthy, hopefully like seaweed or a mango or bok choy. Um, so you can pause the video right now and get that. Alright, so now that you're back, your chewing does not bother me. Be as loud as you want. Put this title down in your notes. It says area of a non-right triangle. And before we start doing that, let's just recap here. A right triangle has one angle measuring 90 degrees. We're going to be using degrees tonight. For a right triangle, we know from geometry that the area is equal to base times height over 2. So for example, this is a right triangle that can be confirmed using the Pythagorean theorem. You should know these for you got your January math meet coming up, all of you mathletes. So yeah, we can use that formula if we just take 5 and 12 as the base and the height. We can just find the area to be 30. That's pretty easy, but tonight we're going to be looking at some non-right triangles. So they may not necessarily have a right angle in them, which can complicate things tremendously. But I want to introduce to you two new formulas here. The first one is the SAS Area Theorem, and it says that the area of a triangle ABC is equal to B times C times sine of A over 2. Just a quick reminder, how we name triangles is A, B, and C are the points. So we call the segment opposite of point A, we call that lowercase a. The side opposite of point B would be lowercase b, and the side opposite of capital C or point C would be lowercase c. So when we look right here, the sine of A is the sine of the angle at A, and then this is side B, the side opposite of point B, and the side opposite of point C. So this, of course, is an SAS relationship if you were to grab a piece of paper and draw that out, or you could just do it in your notes if you would like. So yeah, of course we know from geometry also that one way to prove triangles congruent is to use SAS. So it makes sense that if we know the SAS relationship, we can find one and only one area. So, okay, and then there's another theorem here. This uses really the SSS relationship. And first of all, we're going to start off by saying that S is equal to the semiperimeter of triangle ABC. So semiperimeter, like how a semicircle is half of a circle, a semiperimeter is 1/2 of the perimeter. So I guess you could put that as side A plus side B plus side C over 2 in your notes. Or you can just write down that it's the semiperimeter because semi means half. Okay, so the theorem states, this is Heron's formula, that the area of triangle ABC is equal to the square root of S times S minus A times S minus B times S minus C. So go ahead and pause the video if you need to. Get these two formulas into your notes. They're very important. Alright, so let's look at an example here. For this first example, I'm going to say find the area of a triangle with side lengths of 7, 12, 13. Now, you know this is not a right triangle, so why don't you go ahead and pause the video and try to find the formula, or try to find the area of this triangle. Alright, so hopefully you saw that this was an SSS relationship, so it's really easiest to use Heron's formula when you're given SSS in basically every circumstance. So we're going to say that A is equal to 7, B is equal to 12, and C is equal to 13. Doesn't really have to be in that order, but let's just do that, and we'll get that the semiperimeter is equal to 16. Now let's take the area using Heron's formula. We'll get that that's equal to radical 16 times 9 times 4 times 3. Efficiency here, people. Let's find the prime factorization of this. This would be, what, 2 to the 6th times, oh, what am I doing here? It would be 2 to the 6th times 3 to the third. So if you take that, that could be written as the square root of 2 to the third times 3, and then that times 3. So that's 2 to the third times 3 is equal to 24. So the area of this is going to simplify to 24. Then we have that 3 at the end, so that would be 24 radical 3. Okay, I hope that you didn't try to use Heron's formula here. Or I'm sorry, I hope you didn't try to use the SAS relationship here, because that could take a while. But even if you did use Heron's formula, I want you to watch this because you can find it either way. So you would have to bring in, we already learned this, the law of cosines, the law of sines, the law of tangents. You'd want to use the law of cosines here since you're given the three sides, and you solve for angle A, and then you'd say a cos all of that, and then you get that angle A is approximately 66 degrees. And now that you have that angle that's SAS, you have to, though, remember that we're finding our B and C here, so it's going to be whatever sides are next to that angle. So here you're going to have to use B and C. Since we said 12 and 13 are B and C, that's what you have to use, because it's BC times sine A. Okay, and then if you find this, you get it's approximately 41.57, and that's the same as 24 radical 3. So either method would work, but efficiency, we want to do Heron's formula. Alright, so here's the next example. In triangle ABC, A is equal to 2016, B equals 2870, and C equals 54 degrees. Find the area of this triangle. So go ahead and pause the video here. Alright, so you gave it a shot. Let's see. You should have used SAS Area Theorem because you were given SAS. So you could basically just plug in the three values here and get that the area is equal to approximately 2,340,453.8. Okay, that would be the best way of doing it, but you could also technically use Heron's formula. I know probably a couple of you did that. So once again, you have to use this law of cosine here, and you're able to get what side C is equal to using AB and side A, side B, and angle C. You get that it is approximately 2345.1, and then you can find the semi-perimeter to be approximately 3615.5, and then you can use Heron's formula here. It's a very long process, but it does give you the right answer, which shows that the formula is valid. We get that 2,340,453.8 answer again. Okay, so the video is getting kind of long now, but I have one more challenge. Just do it in your notebook. The area of a triangle with two sides measuring 80 and 110 is 2016. Find the remaining side. Okay, so just a quick hint. It may seem best to use Heron's formula because you're given like SS, but try to use SAS because it's going to be nearly impossible to find that third side using SSS. It is possible, but try to use SAS. Okay? And have a good night.